Okay, so we're going to solve for 3 equations with 3 different unknowns. So if you look, we have an x, a y, and a z. Those are going to be our variables in this question. And this, if you guys recall, looks very similar to our equations of a plane, right? The only difference is in Cartesian form, they're usually set equal to 0. They just move the values over to the other side of the equation. So we're getting used to solving for a specific coordinate if we have 3 planes. That's the idea. That's what they're prepping us to do here. So what we need to do is get organized with how we're going to do this. The first step is to eliminate one of the variables, whether it's x, y, or z. And we're going to use elimination to go through this. Okay? So the first thing I'm going to do is I'm going to look and I'm going to make a decision that I want to eliminate x as my first step. When I'm doing that, I quickly notice that equations 2 and 3 already have the same coefficient. So it'll be very simple to eliminate x if I work with those two. And I'm going to need to do it twice. So I'm going to pair up equations 2 and 3. And I'm going to pair up equation 1 and 2. Okay? And what I'm going to do in that equation is I need the coefficients of x to be the same. So I'll have to manipulate equation number 2. So I'll show you the first one. Let's work with equations 2 and 3 to start. So equation 2 reads x plus y plus 2z equals 31. Okay, I want to move this over so we have some room. And since I find addition the easiest mentally, I want to add these equations. What I'm going to do is I'm going to take equation 3, but I'm going to multiply it by -1. The reason I'm going to do that is because it's going to give my x a negative coefficient so that when I add positive x and negative x, they'll eliminate each other. Okay? So there's a lot of forethought in this. We'll have negative x plus 2y plus z is equal to positive 17. Okay? So the idea here is we're going to add the two together. So when we add them, I'm going to call this new equation I'm creating equation 4. X and x will eliminate. Y plus 2y gives us 3y. 2z plus z gives us 3z. And 31 and 17 gives us 48. So here's my equation 4, and I'll put it in blue so that we realize this is a whole different equation. Okay? I should have did a different color there. Oh, it's okay. I'll now do equation 1 and 2 in purple. Okay? So equation 1 again, I'm going to rewrite it. We have 2x minus 3y plus z is equal to 6. And for equation 2, again, I need the coefficients to be the same. And since I like adding, I'm going to take equation 2 and I'm going to multiply it by -2. So that the coefficient in front of x becomes -2x, -2y, -4z is equal to -62. Yeah, and it fits. Perfect. Now that I've done that, I can eliminate x from both of the equations when we add these two together, and keep in mind we're adding. Okay? And you can subtract if you like. I just like to add as we go through things. We'll do this equation in black. No, I want to do it in blue again. I lied. So when we add them together, -3 and -2 is -5y. And z and -4y is -3z, not y. And when we add these together, we get -56. All right, -56. And I'm going to call that equation 5. So there's our first step. I've created 2 new equations. So equation 4 and equation 5. I'm going to stack them together and take a look at them on top of each other. So we have 3y plus 3z is equal to 48. And we have -5y minus 3z is equal to -56. Well, if I look at this quickly, normally we think alphabetically, let's go to the next variable, let's eliminate y next. We could do that, but if you look at it, z is already set up to eliminate very simply. If I add these 2 equations together, we're going to get rid of z, and we'll have an answer for a y variable. So I'm choosing to jump ahead. And it doesn't matter which one you eliminate first, second, or third. The goal is to get down to one variable. Okay? So I'm going to add these 2 equations together to create equation 6 in green. Okay, so equation 6, and I'm going to add the two together. When I add these two together, we'll get negative 2y. The z's will cancel out. And when we add these together, 6, 7, 8, negative 8. Which means I can now isolate for y in equation 6. Y will then be equal to the value of 4. Okay? So now that I've done that in equation 6, I'm going to take this value of y, and I can plug it into either equation 4 or equation 5. The reason being, we'll only have to isolate for z next. We have a value for y. Okay? So I'm going to take, I can't remember which one I did before, but let's just take equation 4 here. So equation number 4. I have 3, and we're going to substitute in for y, the value of 4, plus 3z equals 48. We then get 12 plus 3z equals 48. 3z is equal to 36. Z equals 12. Perfect. I have two answers now. We have an answer for y, an answer for z. Now what we have to do is go back to our first step. So one of these three equations, and any three, our answers should fulfill them properly. I think it's pretty easy if we look at 2. Right? Our y and our z don't have very difficult coefficients, so I'm going to plug into equation 2 here to solve. So I'll do that in red. Equation 2 was written as, and we could have chosen any of the 1, 2, 3. X, y, 2. X plus y plus 2z. Is it 31? It's equal to 31. Okay. So we're now going to replace the y in this equation with 4. We're going to replace the z in this equation with 12, and we're going to solve for x. X plus 4 plus 24 equals 31. X plus 28 equals 31. X is equal to 3. Is that right? That's right. So our answer to this equation, or a solution that fulfills all three, is x is 3, y is 4, and z is 12.